All right, so I'm gonna go over the review here. So here we go for assessment number 5. So question number 1 is from an earlier uh, item, or earlier knowledge, I guess. So remember, with your quadratic formulas, you have a goes with x squared, so a must be 4. B goes with your x, because remember it goes like this: ax squared plus bx plus c equals 0. That's your generic quadratic equation. So b must be -2 and c must be 5. So we're going to start our quadratic formula. Remember, our quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so my formula starts off like this: negative of b, so a negative of -2 is +2, plus or minus a square root over 2a to 2 times 4 is 8. So I do have a spot down here for us to find the discriminant, so let's do that. So my discriminant is this piece inside the radical right there, b squared minus 4ac. So to do that, I need b squared, so I need -2 squared, which is 4, minus 4 times a is 4, and c is 5. Okay, so I get basically 4 minus 80. So 4 minus 80 turns into -76. So -76 goes in there. All right, so I have two things to do. First of all, that negative cannot stay in there. Remember, that's going to become an I when we bring it out, an imaginary number. And 76 needs to be reduced. So 76 is, let's see, 2 times 38. Right, and then 38 is really 2 times 19. So 76 is going to turn into 2 radical 19, and it has a negative, so it has an I. So I get 2 plus or minus 2i radical 19 all over 8, and make sure that bar comes all the way across there. All right, so remember, if these three parts, these three pieces right here, all divide by a number, you should go ahead and do it to reduce it even further. So I'm going to get my answer to be 1 plus or minus, I could put 1i, but I'll just put I radical 19 all over 4. All right, so based on this solution that you calculated, which we did, how many x-intercepts will you be able to see on the graph of this parabola? So you can graph the parabola just to check, but what's going to happen here is this parabola is never going to touch the x-axis. I don't know if this isn't the correct graph, but because this has an I right here, this imaginary solution, then it's going to be above the x-axis. All right, I can tell it's above because it has a positive x squared facing up. It's not supposed to touch the x-axis. So how many x-intercepts will we be able to see? You'll be able to see no x-intercepts. Because if you see an x-intercept, it means there's a real answer, and there's not. All right, for number 2. Just a straightforward synthetic division problem. When I look at this problem, I have k to the third, k squared, k, and then a constant, so there's nothing missing. It's all in order. Remember, if you're dividing by k plus 5, you put the opposite. You put -5 because you're testing the -5 as a 0 in a way. So 6, 27, -24, -53. I'll draw a line. The 6 comes down. 6 times 5, -5 is -30. I add, so I get -3. -3 times -5 is 15. I add, and then I get -9. -9 times 5 is 45. I add again, and I get -8. So that's my remainder. So remember that when we put this in here, this was k to the third, so this is going to be k squared, and this is going to be k. And so if I look around, and especially for this -8 right here, there's my answer, letter A. The remainder always goes over what you are dividing by. Alrighty, so going on to number 3. Draw a polynomial that has zeros at -3, at 1, and at 4. And it has to have this end behavior. So as x goes to -infinity, the y value goes up. So that means the left side goes up, and as x goes to +infinity, the y value goes down. So the right side goes down. So basically know that the left side, after it touches the x-axis here, it goes up. The right side, after it touches here, goes down. And there could be more to it, but I mean, this is what has to happen. And I'm just going to do the basics. So if I'm traveling here, I'm going to come around and touch at 1. I'm going to come back up and touch there. It could be more complicated than this, but this is basically the easiest thing I can draw that has these characteristics. All right, and number 4, use synthetic division to prove whether or not x minus 3 is a factor. So we're going to do the same thing that we did in number 2, but we're looking for a remainder of 0. If something is a factor, that means there is no remainder when you divide. Just like, 2 is a factor of 10, because 10 divided by 2 is 5, and there's no remainder. Okay? So x to the 4th, x to the 3rd, x squared, everything's in order, nothing's missing. So I'm going to put a 3 right here in the box, because x minus 3 means I'm testing for the number 3 as a 0. So I have a 1, negative 7, 14, negative 3, negative 9. So bring the 1 down. 1 times 3 is 3. Add, get negative 4. Negative 4 times 3 is negative 12. Add, get 2. 2 times 3 is 6. Add, get 3. 3 times 3 is 9. And we do get a 0. So yes, it works. So the answer to this question is yes. And it's because the remainder is 0. And if we wanted to know what the dividend was, we would, remember, put an x to the 3rd right here, and x squared right there, and an x. So this is the answer to that division problem, that f of x divided by x minus 3 is this answer right here, if we needed to go any further. All right, number 5. Factorize the sum of these cubes. So remember that we can write it like this. This is really 3x to the 3rd power plus 5 to the 3rd power. So these are the things that you are cubing to get this problem. All right, so when we want to write the factors, remember we have a little piece and a bigger piece. So we have a binomial here. We would take that 3x and we take the 5. Then over here, remember we're going to do square, multiply, square. We learned this right before break. So I have to square my 3x, so that means I have 3x. I have to square it, so that gets me 9x squared. Then I have to multiply 3x and 5 together. Notice I haven't put any signs in, so that gets me 15x. Then I have to square the 5, so it's 25. And then I come through with SOAP. Remember, same, opposite, always positive. So same means I'm going to be putting the same sign as the original, so plus. Opposite means the opposite of the plus is a minus, and then this is always positive. All right, and the last one here, number 6, what's the end behavior of this polynomial? Well, if I look around, I hope I didn't trick you on this one, but the degree here is actually 4. So if I look around here, there's the highest power. It's not sitting up front right there. So just be careful. It's an even number and it has a negative in front, right? So an even number with a negative, even degrees mean they both go up, both ends go up, or both ends go down. So since it's negative, both ends are going to go down. It looks like this. So both of these are going down to negative infinity. Okay. All right. Now, number 7. Number 7 is a big question. It's kind of simple to do, but it just covers a lot of different areas, so make sure you understand each one, because the question will be broken up into pieces when you do your test, but it'll have all these concepts. So, which sections A, B, C, and D or D are decreasing? So I'm talking about these sections right here. You notice you have here, 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 here. So you have 4 sections to this graph in a way, if you want to think of it like that. And when you're doing this, notice how I started at the left. I went down, up, down, up. So these two right here, down, up, down, so those two are decreasing. So section A and C are decreasing. That's the 2 increasing intervals of this polynomial. So that's section B and D. So B, so now I really want the answer. So remember B and D, remember you have to use the x values of these to name them. So B is named by saying negative 1.5 to 2. Because what you're doing in a sense is you are naming the area. You're saying, oh, from right here all the way to 2. This section of your graph from negative 1.5 to 2, that whole green section is increasing. And then you're naming the next area right here, this whole section is increasing. And so what you're doing in a sense is you're saying from negative 1.5 all the way to 2, and then over here from 4 to infinity. So the next answer is 4 to infinity, and that would be section D. List the coordinates of the local maximum point. So there's only one local maximum, and that is this one right here, 2, 0. It's not the highest on the whole graph, but it is the highest in its area. Remember, local could also be called a relative maximum. So that's 2, 0. All right, letter D, list the coordinates of the two local minimums, or relative minimums. So here, this is a low spot, this is another low spot, so negative 1.5, 4, sorry, negative 4, and also 4, negative 1. After writing these points, circle the one that's actually the absolute minimum. So absolute minimum, remember, means the lowest on the whole graph. So that would be this guy right here. He's the lowest spot on the whole graph, the lowest y value, so him. All right, what's the coordinate of the y-intercept? So you're only ever going to have one y-intercept, and there it is. So 0, negative 2. Any graph, any function only has one y-intercept. All right, what are the coordinates of the zeros? So zeros, so there's one right there, negative 3, 0. The next one happens at 2, 0. And the last one happens at 5, 0 right there. Which of these zeros is a double root because of the bounce? So the double root is right here. So remember, it's bouncing off of 2 and going back away from that. So which of the zeros? So the 0 at 2. Or you could have written 2, 0, whatever, but 2 is a double root in this problem. X equals 2. All right, shade or circle the factors below that would be factors of this polynomial. Well, so we kind of already took care of that. That relates to problem F right here. So negative 3 would turn into x plus 3. 2 would turn into x minus 2. And the 5 right here would turn into x minus 5. Right, and if you had to write this problem out, the x minus 2 would have a square on it because it's a double root, but you haven't been asked to do that. All right, and our last problem here. So part of this problem is done to make it a little bit simpler and a little bit easier to go through and finish. But the polynomial y equals 2x to the third plus 7x squared minus 7x minus 30 has an x-intercept at negative 3. So normally you would get that by looking at Desmos and seeing, oh, look, it's crossing at negative 3. Okay, but I've already told you that, and you don't have to look. All right, the synthetic division with that 0 is shown below. So I've done the synthetic division. I've pulled all these coefficients, and I've put negative 3 here in the box. And so already I kind of know one of the zeros. One of the zeros is negative 3, and the factor that goes with that is x plus 3. But I have to find 2 more, because remember, we have to have 3 answers. All right, so the remaining 2 solutions can be found by factoring. So I'm telling you that, so I want to see it. So remember that when you take one x out, that means that you have x squared, and you have an x right here. So what I'm trying to do is 2x squared plus x minus 10. I'm trying to solve this by factoring, basically. I've told you that it factors, so let's do it. So let's see. So I know I need 2x and x. For 10, let's try 5 and 2. I can't put the 2 here, so I'll try the 5 here and the 2 there. Let's check it out. So when I try that out, I see this part is 4x. This part is 5x. I can get 1 from that, positive 1. So positive 5 minus 4 is how I'm going to have to get this 1 right here. So plus here, minus there, and there we go. There are my last 2 factors, 2x plus 5 and x minus 2. And then that means that the last 2 zeros, remember, I could take 2x plus 5 and set it equal to 0. Take away 5, divide by 2, I get negative 5 over 2. And the other one, x minus 2 equals 0. Add 2, I get x equals 2. So there are the last 2 zeros. And they are proven not by looking at the graph, they are proven by having the synthetic division done, it comes out to 0 as a remainder, and then I further go on and show the factoring and then get my solutions that way, okay? You can't just look at the graph and be like, oh, I see it, okay? All right, that is it. Bye-bye.